Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Azril Azmi from J4EM1104N. Today I want to talk about experiment F1. The title is Hydrostatic Force on Plane Surface. For the objective, there are three objectives. The first one is to determine experimentally the magnitude of the force of pressure, hydrostatic force, and its point of action, center of pressure, on both submerged, partially submerged plane surface. B is to compare and analyze the experimental result with the theoretical values. And the last one is to learn how to calculate the theoretical and experimental second moment. For the apparatus, for the first is a counterweight, and second is a tank. The third one is a drain valve. The number four is a adjustable feet, and number five is a balance arm. Number six is a quadrant here, and number seven is a balance pointer. Number eight is a balance pan. Number nine is a weight. Number 10 is a depth of immersion scale. Here. Number 11 is a spirit level. For the procedure, first, place the hydrostatic pressure apparatus on top of the bench. Make sure that make sure that the apparatus is installed properly. Number 3 is level the apparatus using the adjustable field facilitated by the spirit level attached. And then adjust the counterweight to level the balance arm to horizontal position. Number 5 of procedure is make sure that the drain valve V16 is closed and slowly add water into the tank until the surface just touch the quadrant base, thus establishing a datum level corresponding to 0 at the level scale. Next, place a 50-gram weight on the balance pan and slowly add water into the tank until the balance arm is again horizontal. Number 7. Record the mass of weight M and depth of immersion D in the experimental data sheet. Number 8. Repeat step 6 and 7 with increasing number of weight until the tank is full of water. Number 9. Drain the water after the experiment is complete by opening valve V16. For the table, For the graph, I take hydrostatic force versus second moment incremental and second moment theory. Is the red one is a second moment experimental and the green one is a second moment theory. So this is the graph. Okay. For the calculation, uh, for the resultant hydrostatic force F, I use rho g times bd square over 2. For the rho is and for the second moment experimental, I use mgl over f. This all is for partial immersion. And the second moment theory, I use h minus d over 3. For the percentage, I use second moment theory minus second moment experimental divide by second moment theory times with 100 to get the percentage for the error. For for the experiment that fully emerged, the equation will be different. The equation will be F for the resultant hydrostatic force. F is rho g times capital B and capital D in bracket D minus capital D over 2. Then for second moment experimental, H prime prime, MGL over F is the same, and for second moment experimental, D in bracket D minus D over 2 square plus D over 12 square plus H minus D. Sorry, d minus d over 2 square plus d over 12 square divide by d minus d over 2 plus h minus d. And for the error, I still use second moment theory minus second moment experimental divided by second moment theory time with 100.
In conclusion, this experiment really helps in modern industry such as Hoover Dam and others. The data gathered from the pressure system also backs up the relationship between variables as seen in the equation for calculating hydrostatic force, the center of pressure, and mass. To put it another way, the hydrostatic force, if the height of the fluid in the chamber rises, the force acting on both partially and fully submerged vertical rectangular surface increases. The application of this lab is submarine, transportation and storage, and medicine. That's all from me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.